So we are being asked to find the value of x in this hanger diagram and this equation. So we're going to start working with both so you can kind of see how we're going to go from this to that. So looking at this hanger diagram, what do you see? Well, I see two groups of x plus 5 is balanced with 16. So if I take and think of this as a group, and this is a group, and that's what this is, two groups of x plus 5 equals 16. So if I split this right here, and I say this group right here is going to equal 8, and this group right here is going to equal 8, because I took that 16 and I split it in two. So now we have, and we can look at either this one or this one, because they're exactly the same. So now I have x, and hanging with it is 5, and altogether they are balanced to equal 8. So I want x by itself. That is my goal when I solve equations, is to isolate the variable. And remember, the variable is x. So I have this 5 here, and it's hanging there with x, and I want it to go away. So I'm going to take it away. Well, as soon as I take it away, I'm now lopsided. I'm no longer balanced. So what I have to do is take away that same 5 from this side, which would make this 3. Well, now it's balanced again, and now we know that x equals 3. And the same thing is going to happen down here, because it's two groups of the same thing. So if I take away 5 here, I get 3 here, and I still get the same x equals 3. And you don't have to do the bottom one. So now let's come over and start talking about what it's going to look like when we do with an equation, because at some point we're not going to draw tape diagrams or hanger diagrams. So what I always start with is an upside down T. The reason for that is it helps me see that I have to do something on this side, and I'm going to do the same thing on the other side, and it's always at the equal sign. So what did I do over here first? Well, I split it into two groups. So I divided this by 2, divided this side by 2, and then I came over here and I divided this side by 2, because whatever you do over here, you have to do over here. And there's a property or a rule that says we can do that, and this is the division property of equality. All right, so when we divide this here, these 2's, 2 divided by 2 is 1, so I'm left with x plus 5 equals 16 divided by 2 is 8. So now I have something, x plus 5 equals 8. Well, I don't have my variable by itself yet, but I'm getting closer. So I'm going to do my upside down T again, right at the equal sign. What's hanging there with x? Well, hanging here is 5, and we want 5 to go away. So we're going to put the opposite of 5, which is -5, or if you think of this as plus 5, I'm going to do minus 5. If I do minus 5 on this side, I'm going to do minus 5 on this side. So 5 and -5 are a 0 pair, so that I now have isolated the variable. I've got x by itself, and x minus 8 minus 5 equals 3. So I get the same solution, so I know I've done it right. Now, can we check it? There's always a way to check. Said that x equals 3. So I'm going to go back to the original equation, and I'm going to plug in a 3 where the x is, and I'm going to say, is it equal to 16? Because I'm checking. This is the check. And it's always a good idea to go back and check. So looking at this, 3 plus 5 is 8. And then I'm multiplying it by 2. 2 times 8 is 16. And I wanted to get 16, so we did it properly.